Okay, guys, so welcome to the new lecture. Okay, so I hope all of you are there in the lecture. Okay, so guys, we have started with our neural network classes. Okay, so we see how to create a simple neural network. Okay, we have been working so much on Keras. Okay, so guys, we can work on PyTorch also. Okay, so we will see the difference between the Keras and PyTorch. In the PyTorch, we will be building the classes. Using the classes, we will be creating the neural networks. Okay, so be patient. Maybe next week we will start PyTorch. Okay, so till then, we are discussing about handwritten digit data sets. Okay, so we have seen all these things. Okay, so just wait a second. Yeah.
Recording in progress.
So welcome all. So today we are going to discuss about Keras. Okay. So in the Keras we will see how to build a neural network. Okay. So we will be taking. Okay. So we'll be taking a data set of iris flower data set. Okay, so guys, you know the three types of iris flower. It is virginica, versicolor, setosa. Okay, so we will be taking the data set of iris flower. Okay, so you know already about this data set as we have done machine learning task using this data set. Okay, this is a classification problem. Okay, so same thing now, guys, we will be doing with the neural network. Okay, so we will be using Keras for it. Okay, so same things what we are doing, which problems we are solving, we will solve in PyTorch also. Okay, so just be patient. For the next week we will solve all these problem using PyTorch also. Okay, so guys, let's start with the discussion. Okay, so iris flower data set. So I will be going to share my screen here. Okay, so guys, can you see my screen, all of you? So give the chat, like write in the chat if you can see my screen. So guys, this is the iris flower data set. Yeah, it's of three types. Okay, so as we all know, Setosa, Virginica, versicolor. So these three types of flowers we have in this. These are the categories of the iris flower. Okay. So now guys, we have given this data set. Now the challenge is to make a neural network, okay, which can predict okay, so given the features, we need to predict okay, whether this feature belongs to Athatosa, Virginic or versicolor. Okay, so guys, if you know, features are petal length, petal width, sepal length, sepal width. Okay, so if you remember our lectures in machine learning, we already taught about these things. Okay, so guys, so these four features basically the flower has. Okay, petal length, petal width, sepal length, sepal width. Okay, so using these four features, value of these four features, we can say that the flower is Setosa, Virginica or versicolor. Okay, so guys, these four features will help you. These four features are the independent features, and dependent feature will be the type of the flower. Okay, okay, so guys, I think these are the basic things you already know about this. Okay, so yeah, okay, so let's move ahead. Okay, yeah, okay, just give a second. Yeah, so any doubt till here? Okay, so let me share my slides once again. Okay, yeah, good. So any doubt till here? Okay, yes, yes, good. Yeah, so guys, open your Jupyter Notebook or Google Colab. Okay, so we will be seeing about this. Okay, but before that, let's do some revision of the features we have. Okay, so we can see, please read it. I give you some time So there are four features: sepal length, sepal width, petal length, and petal width. Okay. So these guys, these values are in centimeters. Okay. And target feature is our uh, Satosa virginica versicolor. So any three multi-class classification. Okay. We can say that. And soft max will be used in the outer. Okay. So for the output layer, softmax activation function will be used. Okay. What about the hidden layers? Again, ReLU activation function will be used. Okay. What about the optimizer? So we will be using the Atom. Okay. Please explore about this. Why Atom always? So little bit study you have to do. We will discuss. Okay. Don't worry. Okay, so these things you should, when you see the problem, these things should be in your mind, okay? That these things should be clear, okay? Please read it, take 5-10 minutes, okay? So data set is small, okay? So where, so deep learning is used when data set is huge, okay? But here data set is small, so we can do using machine learning also, okay? Deep learning is for when you have huge amount of data, okay? When you're working on images or audio, video. So guys, there are many things actually to learn in this, okay? So it's very exciting journey, okay? So are you all listening? So can I see yes in the chat if you are listening to us? Yeah, good, good. So people are interactive, very good. Okay, okay, good, good. So guys, let's start with the coding without wasting any time. Okay, so please open your Jupyter Notebook or Google Colab. Okay, so I will suggest you to go with the Google Colab. Okay, because it provides you the GPU facilities also. Okay, yeah. So now I am opening it. Okay, so now I am going to share my screen again. Okay, so guys, I will suggest you to do yourself today. Okay, so let me check that if you are able to do it, as we have solved lot of problems till now. So I think uh, you must do it, okay, yourself. Okay, so guys, the first step is to importing the libraries again. Okay, so why to use NumPy? Okay, who will tell why to use NumPy? It is for yeah, so who will tell? Okay, so NumPy is a short name given as NP. Okay, okay, so TensorFlow. Okay, so importing the libraries. Okay, Keras. So Keras is built on top of TensorFlow. Okay, so we are using Keras here. Okay, so we are importing the layers and models. Okay, so we have many layers to be added like input layer, hidden layer, output layer. So we need this layers. Okay, train test split again. You remember the machine learning thing. So we are separating our training and testing data. So how much percentage of the data will go in the training and how much will go in the testing was decided in this method actually. Okay, so now we are using the default iris flower data set. Okay, so we are importing it from sklearn. Okay, okay, so that is also a thing. Okay, and the standard scaler, we will scale our features. Okay, so we will scale our independent features. Okay, so that the mean is 0 and standard deviation is 1. Okay, so you have to remember all these things. Okay, so can you see my screen? I am already sharing my screen. How many of people can see my screen? Okay, is that the Jupyter Notebook one? Okay, so can you see the screen? Okay, yeah. I think it is visible. Okay, so guys, start doing with me. So first step is to import the libraries. So I am sharing with you the code in the chat also. Okay, but I will recommend you to write own. Okay, the more you write, the more you will learn. Okay, yeah. I am sending the code in partial. Okay, not sending directly. So this time you have to write little bit. Okay, so yeah. Okay, so the next step, okay, so load and pre-process the data. Okay, so I am sending the code in, okay, step by step, like step one code, like everybody need to execute step one code. Okay, first import all the libraries. Okay, done all of you. Okay, so step by step we can execute this time. Okay, so this is the, okay, so you can say now this is the sections, guys. So we have created a section. Okay, and in this section we can hide also. Okay, so step one code is this. Okay, yeah, okay, so let me share this notebook also with you all. Okay, so yeah, so let's wait. Okay, so I share you the notebook. Okay, yes, yes. Okay, okay, so I will send on the WhatsApp. Okay, just after this lecture. Okay, yeah, be patient. Okay, so first of all, importing the libraries, guys. So you know the libraries. Okay, so we have imported it. Okay, second step is to load the data. Okay, so we will load the data. Okay, so we are loading the data. Okay, and separating the independent and dependent features. Okay, so guys, you can print always, you can print this independent features like sepal length, sepal width, petal length and petal width. Okay. So you can always print it. Okay. So like I am printing here X, I am printing here Y. So when I run this code again, I will get to know that. So you can run again codes like this. Okay. So cell by cell it is executed. Okay, so first cell is executed, all the commands. Okay, then this cell is executed. Okay, so now guys, what I will see in the output is I will see the features. Okay, so all the independent features and the dependent features. Okay, so guys, this is it, and we have the four independent features. Okay, and these are the values for it. Okay, four, you can see four values for each row. Okay, and you have to scroll little bit. Okay, so okay, and this is all the x-axis independent feature, and this is the y-axis, guys. So we have y dependent feature. Okay, so these are the three classes. Okay, so 0 1 2. So 0 for first category, 1 for second, second for third category. Okay, so this was easy. I think you have done already in machine learning. This is not a new thing if you practice. Okay, then we do scaling. So we will scale the data. Okay, so that mean is 0 and standard deviation is 1. Okay, we scale the data so that model don't think that this feature is more important, this feature is less important. Okay, so every feature is equal, so that's why we do scaling. Okay, so scaling, so we have to create an object of this standard scalar. Okay, so then we have to do fit transform. Okay, so we are okay. First we are training and then we are transforming. In the single step, we are doing both the things. Okay, so yeah. So now we have this train test split method. So it will separate the training and testing data. 80% will go in the training, 20% will go in the testing. Okay, so that's it. So guys, I know you know already these things. Okay, but the new thing will start little down. Okay, building the neural network. Now this is the main thing. Okay, so now we are creating the model here. So we are, okay, we are defining the neural network architecture. Okay, architecture, how many layers will be there. Okay, what is the input shape. Okay, input shape means features. Okay, how many features? Four features. Either you can directly write here four, or you can directly write like this. Okay, so in the hidden layers, we will use the ReLU activation function for the hidden layers. And for the output layer, we will be using the softmax. Okay, because flower can be of three categories. That's why we have to use softmax as a activation function for the output layer. Okay, so guys, main thing is this, I think. Okay, rest things you know already. Okay, so yeah, so kindly see in the chat, I have shared you the code. Okay, Okay, so this is way how you will build the neural network. Okay, uh, okay, so using the sequential, why sequential? Because in the sequential we have single input and single output. Okay, it is not the functional API, it is a sequential API. Okay, so at least basics you should know. Okay, yeah, good. So, acha, some people are saying that they missed. Okay, step one was this, guys. Please don't miss your steps. Okay, step one is importing the libraries. Second step is loading and pre-processing. Okay, so I send you the step two again. Okay, yes. Everybody, please complete this. Okay, please find in your chat all the codes. Okay, yeah. Step two I have shared. Okay. Yes, I think it is okay. It is sharing to all. Okay. So guys, I recommend you to write yourself, okay, instead of copy pasting, it will take little bit time only. So guys, we have today's a task of CNN, how you will add the CNN layers in this. Okay. So you have to do this. Okay. So we will see everyone is doing for this. So step one, please complete importing the libraries. Okay. Step 2, loading the data, separating the independent and dependent feature. X is independent, Y is dependent. Y means all the labels 0, 1 and 2. Okay, these are the types of the flowers of iris. Okay, and X are the features: petal length, petal width, sepal length, sepal width. Okay, 4 features. Okay. Okay, so please guys, this is very easy. If you don't practice, you will forget. Okay, so by standard scalar, because every feature need to be on equal scale. Okay, no feature is greater, no feature is lesser. Okay, that's why we are using standard scalar. Okay, in the standard scalar, mean is 0 and standard deviation is 1. Okay, so guys, complete this. Okay. Yeah, so now guys, third step again, building the neural network. Okay, so guys, you need to add here the CNN layers, okay, like convolutional layer, max pooling layer. So these type of layers you have to add, okay, and you have to see the accuracy. Okay, please add the CNN layers and check if the accuracy is increasing or decreasing. Okay, so little things you have to do. You have to be little smart today. Okay, why softmax? Again, multi-class classification. Okay, three classes are there. Okay, so we have to categorize the data. Data can belong to features if provided to you, can belong to one of the flower. Okay, yeah. Okay, so please experiment. Can I increase more? Can I increase more layers? Yes, we can increase. No one stop us. So we can increase more layers, guys. Okay, so we can increase the neurons. This is the neurons. So guys, we are trying to increase the neurons and see whether the accuracy is changing or not. Okay, so you have to experiment like this. Okay, like 64, okay, 32. So you can have like this. Okay, hidden layers are always having the ReLU activation function. Okay, these are the hidden layers. First is the input layer, last is the output layer. Okay, so guys, please practice. Okay, so we can motivate you, but you have to do yourself. Okay, so please add all the CNN layers now. Little things you have to do yourself. Okay, but guys, please remember the last layer, the output layer. Don't change the number of neurons. Okay, so neurons are 3, it will not change because of multi-class classification. How many classes? 3 classes. Guys, it is easy. Okay, so it is not hard. Okay, just a practice. Okay, so now the next step is to compile the model. Okay, so now we will be using the optimizer as Adam. Okay, okay, most of the time we will use this. Why the matrix is accuracy? Okay, so because we are trying to solve a classification problem. So, so the accuracy is the how well the model is performing. Okay, performance of the model can be measured using the accuracy. Okay, yeah. So Guys, please do it. I'm sending the code. Okay, so please check your inbox. Okay, so I'm sending all the codes. Okay, okay, so once we compile the model, then we will train the model. Okay, so here we have decided the epoch says 50. Okay, so 50 times the same data set will be used to train the model 50 times. Okay, and for each epoch, okay, each epoch you will get some accuracy. Okay, so accuracy will increase as the epoch increases. Okay, and loss will decrease. Okay, so loss will decrease and accuracy will increase. Okay, so you have to think like this. Okay, so first you train the model, then you test the model, you do predictions. Okay, so this is the way, guys. Okay, start playing with the parameters like batch size. So 16 of batch will be processed at a time. Okay, you can always increase this. Okay, so kindly do it. Okay, if batch size is more, then processing will be faster. Okay, so you have to see, observe it after running the code. Okay, and validation split. Okay, so how much data will go in the training, how much data will go in the testing. Okay, okay, so these guys, these things are very easy. Okay, you know already, so please start doing this now. Okay, so once you train the model, okay, you can see also the accuracy is increasing, but you have to check for the testing validation accuracy. Okay, yeah, and guys, in the last, we are predicting now, evaluating the model on the test data. Okay, so if we give the test data and what is the accuracy? Okay, so see, when I'm training you, if I ask some question, you give the right answer, it's fine. But when I take your test and you don't perform well, then what you will say? Then you will say that training was not good. Okay, so that is also one scenario. Other scenario can be if you can perform good in training and good in testing. So this time, guys, I think they have performed good in training and testing also. Okay, because if you see the training accuracy, it is 93 and testing accuracy is 96. That means they are very close to each other. So there is no overfitting. Whatever I teach you, you write same thing in exam. Okay, exam also you perform good. Okay, so that means there is no overfitting. Okay, you can say like this. Okay, so step 6 is evaluating the model. Okay, so this is the guys accuracy which is coming. Now we are visualizing the accuracy of training and testing, training accuracy, validation accuracy. So guys, you can see as the epoch increases, the training accuracy increase and validation accuracy is also increasing. Guys, you can see these lines are very close to each other, so there is no overfitting. Okay, so we can say that there is no overfitting. Okay, so overfitting problem is almost very less. Okay, here as the epoch increase, loss is also decreasing. Okay, so guys, these things are repeating. If you observe carefully, these things are repeating. Okay, so start doing now. I have explained each and everything of this code. Okay, yeah, so can you share now, guys? It's your turn. Can you share me the accuracy which you are getting? Okay, so let's see whose people are doing. Show step 6. Okay, let's see. So guys, if you have done train the model, then step 6 is to prediction, do the prediction, model will do the prediction, and we are finding the accuracy of the model. Okay, so now as we have trained you, now it's time to perform outside how you're performing. Okay, so when your test happens, what is your score? Okay, so that means this thing. So I am sending you the code again, guys. Please see it. Yeah, so Vignesh is very good. So Vignesh is getting the accuracy of 88%. Very good. Vignesh is faster. So guys, please now you have to do for CNN. Can I add the CNN layers in this? If you are able to add CNN layers, then tell me the accuracy. Today you have to do something, okay? So guys, this is the step 6, okay? Yeah, good, good. So Sri Chandra is getting 93% accuracy. Okay, good. So Vignesh is getting 88. Okay. Yeah, so validation is 91. Okay, okay. Yeah, guys, so we have to see the validation accuracy only. Okay. So if the validation is less, then there is a problem. Okay, then you have to do something else also. Okay. Yeah, code for seventh. Okay, okay. Guys, we are last is optional, but we will do that. We are trying to use matplotlib. Okay. So guys, this is the x-axis, this is y-axis. Okay, x-axis we have epochs, y-axis we have the accuracy. Okay. So guys, this is subplot. So one row, two columns. So one row and two columns. What will become first? What figure will come first, what figure will come next. Okay, this last will decide this thing. Okay, so legends are this thing. You can see the legends here: training accuracy and validation accuracy. Okay, if you don't include this, it will hide what will come on x-axis, what will come on y-axis. Okay, and this plot means to draw the line. Okay, so if I write plt, you remember, I think, see guys, we have done the matplotlib class already. So if you are revising it, so how to draw a line? So for the line you need, okay, you need the method that is plot. Okay, so if you revise, then it is easy for you to remember. Okay, what is the figure size? I can play with this width and height. Okay, so you can always change it. Okay, so start doing these things. Okay, I'm sharing again to all. If someone has missed, okay, please add CNN layers now. So let me see who are all doing. So guys, you need to add CNN layer to this, okay, and tell me the accuracy. I will give you 10-15 minutes now. Okay, so it's time for you to add some CNN layers like convolutional layer, max pooling layer, flattening layer, dense layer. Okay, so I'm giving you some hints. Okay, what things we have done yesterday. Now you have to add the layers and tell me the accuracy. Is it increasing or decreasing? What is happening? Okay. So this way you will practice the CNN also once again. Okay. So CNN was designed actually for image classification. Okay. But here we are trying to include that also. Okay. So we can include, actually. There is no condition like that. Okay. We have seen so many codes previously of CNN. Okay. So I will recommend you, if you have get time, if you can do it now. Okay. So you should show us. Okay. Yeah. So guys, this was the first problem which we have to discuss today. Okay. So I think it was easy. Okay. So guys, if you don't know about Iris data set, so I will go to Google sklearn. Okay. Please type with me sklearn Iris data set. Okay. So those who have done the machine learning course, okay, so you can see here. Okay, so this is scikit-learn. This is for machine learning. Okay, so we have different data sets here. Okay, so we have solved lot of data sets, worked on lot of data sets. Okay, so you can choose actually. So I'm sharing the link. You can click on classification. So in the classification, these type, okay, these are the models. Okay, so we have seen lot of models. Okay, so kindly go through with this documentation. Okay, those who are new to machine learning, I think we have covered machine learning, but still, okay, if you want to explore, you can go to these websites. Okay, okay, all these algorithms which we have learned previously are there. Okay, so guys, please complete this. Anyone done CNN? So I am waiting for you all now. Okay, yeah, so you have to do CNN for this code. Okay, how you will, I'm writing in the chat that we will be using convolutional layer. Okay, convolutional max pool. Okay, so you have to now figure out how to do. Okay, kindly start doing. Okay, this will be your first task. Okay, yeah, so anyone doubt? So or only one, two people share your accuracy score. Okay, so Shri Chandra shared the accuracy score. And Vignesh also sent. Others not doing anything. Others people, please share the accuracy score. If you missed some step, we can help you. Okay. If you missed some step, please see once again. I am sharing. This was the step one where we imported the libraries. Second step, loading the data, splitting the data into training and testing. Okay. You can always print the independent and dependent feature. Okay. Okay. Independent are the petal length, petal width, sepal length, sepal width. Dependent feature are the classes. Okay. Whether the flower belongs to 0, 1, 2. Okay. Third is, this is the main thing, guys. So you need to add CNN layers here actually. Okay. So yeah, so who will tell how to add? Okay, so this is your task. Either you do now or you do later on. Okay, but you have to add CNN layers here and show me the output. Okay, so that will be the first task. Kindly complete this. Okay, then we compile the model. Okay, then we train the model. Okay, see guys, early stopping is not there, so kindly add early stopping. Okay, kindly add the callbacks. Early stopping is a callback. Okay, you know already now. So guys, you have to work on this code. This is not a you can say you can improve this code. Okay, you can improve this code using your past knowledge. Okay, like early stopping. Okay, uh, so batch normalization you can do. Okay, so drop out. Okay, so you can drop neurons, 50% of neurons. Please play. Okay, this is very important, this structure. Okay, if you know this, then you know neural networks. Okay, and Keras provide very easy way actually to add the layers. Okay, just add method. Okay, so you can just go to the documentation, guys, if you want to read more. So add a layer on top of the layered stack. This is a layered stack. We are adding the layers. Okay, so first attribute is a layer. Okay, yeah. So someone is asking, sir, what input shape I have to give for cat. Okay, guys, see, if you are confused, just print it. So for your convenience, I will print this. Let's see what will be the output. Okay. So let's see. So if you guys, if you are confused anywhere, you can always print the value. Okay. You can print in last also. See, so if you have done all the things, now you want to check something. So you can always do like this also. Okay. So it is saying that bracket is 4. Obviously, features are 4 now. These are the features. Sepal length, sepal width, petal length, petal width. Okay. So these are the features, guys. Input shape are the features. Okay. So this way you have to give like comma. You have to give, this is a syntax actually. Okay, so please add more and more layers. See if the accuracy is increasing or not. Add convolutional layer, max pooling layer, flattening layer, dense layer. So many layers, many things you can do actually here. Okay, so if you are practicing daily, so you can catch it what I am saying. Okay, yeah. Acha, some people are getting error, so let's help them. So input 0 of layer is incompatible. Okay. Yeah, so guys is using 2D, so don't use 2D here. Okay, so convolutional, okay. Yeah, okay, softmax. Okay, Vignesh, try with 1D. Okay, don't use 2D here. Okay, so guys, I want to help you with this. So sometimes it is very confusing about which to use. So yeah, so always go to documentation, guys. So I can show you the documentation. Okay, so this is a convolutional 1D layer. Okay, so you can use 1D also. Okay, try to for 1D. Okay, yeah, so I actually explained you earlier also about this thing. Okay, yeah, so kindly do it. Anyone tried? Okay. Yeah, so Vignesh is trying for the convolutional. Okay, max pooling. Okay, good. Other people not responding much. Okay. So guys, we have done only one task today. Okay. So please complete this. This was a very easy task. Okay. Yeah. So any doubt everyone completed? Yes, yes, yes. Can we move ahead? Everyone done? Anyone still doing? Yeah, guys, please respond. If you will not respond, what will happen? Okay. So guys, let's move to second part of today's lecture. Okay. So yeah. Okay. So some people are getting errors. Okay. 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 Yeah, working on CNN. Okay, good, good. So guys, I give you 1 day time. Okay, take 1 day time. So okay, so if you are not able to do, then I will send the code. Okay, no worries. Okay, so guys, let's move to second code. Okay, for today. Okay, so this is about the bank loan status. Okay, so you are applying for the loan, so you will get the loan or not. So it depends on many things. Are you married? What is your gender? What is your education? Are you self-employed or not? Okay, so how much year of loan you want? So see guys, when you apply for the loan, it depends on many things actually. Okay, so how many dependents? Father, mother, wife. So three dependents. So maybe you get or not get the loan. Okay, so guys, you are trying to apply for the loan. You will get or not. It depends on where you stay. If you are staying in rural area, then maybe you don't get the loan. Okay, so these are the factors, guys, on which it depends whether you get the loan or not. Okay. Yeah, so guys, those who are working on CNN, please continue with your work, okay, or you can continue after this lecture. Okay, if you're okay, I will send the code after the class, okay, not to worry much. Please focus on this code now, okay. So this is about the bank loan status prediction using ANN, okay. So I'm going to share you the CSV file here, which you can run. First, you understand the code. See, guys, first you understand. Okay, so everyone, please focus here now. So first of all, we are importing the libraries. Okay, so guys, you know already these things, so I will not repeat. So pandas, what Panda having the method as read CSV. Okay, so you can read the CSV, you can convert into data frame. This is the data frame. Okay, so guys, you know these things. So I'm skipping little things because it is a neural network class. Okay, printing the shape, info. Okay, so doing some basic data validations. Okay, uh, task. Okay, so these things are easy. We have to find whether the person will buy the insurance, person will get the loan or not. Okay. So yeah, we are converting into one hot encoding. Okay. Like these categorical features. Okay. So one hot encoding will increase the columns. Okay. So now columns will be increased, like gender is male or female, so two columns will be there. Okay, married or not married. Okay, so we applied one hot encoding. Okay, we remove the columns which we don't want now. Okay, so finally we get 13 columns and so much rows. Okay, then we are using label encoding. Okay, so guys, these are easy things actually, you know already these things. Okay, so I'm just focusing on the neural network part. Okay. Yeah. Okay. I will share this notebook. Don't worry. Just pay attention to the neural network. Okay. So guys, I'm importing these libraries. Okay. Yeah. So about, okay. So someone is asking one hot encoding. Okay. So let's move again. Okay, so starting with importing the libraries, then reading the CSV file, converting it to data frames. Okay, then doing some data validation like shape. Okay, so 13 columns, these many rows are there in the data set. Info will give you the, uh, you can say the data type of each column. Okay, and how many null values are there, non-null values. Okay, uh, df dot duplicate the sum, so if any duplicate values are present or not. Okay, Then removing some columns which we don't want, like loan ID. So using loan ID, we cannot predict, we cannot do anything. Okay, so we will include only those features that help us to determine whether the person will get the insurance or not. Okay, if any column, irrelevant column is there, we will remove it. Okay, so these steps are easy. So now see carefully. Okay, so now I open my notepad here. Okay, so suppose gender. So gender can be male or female, male and female. Okay, okay, we write simple M and F. Okay, so for one hot encoding, it will create two columns. Okay, so now two columns will be there. Okay, yeah. So if the guy is male, so the answer will 1 and 0. Okay, if the guy is female, it is female, so we will have this. So we are increasing the columns. Okay, so you can also see here. So for the gender, okay, so for the gender, gender can be male or female. Okay, so gender male, all it is one. Okay, and so similarly, married, yes. So it is married, so it is yes. Okay. So you can see why the second column is not there. See, guys, it is logical. So if it is, so if the person is male, okay, so why to show the female? If it is zero, so you can remove any one. So now why to create two columns? Okay, so if you can adjust with one, if I remove this first column here, okay, so if I remove now if female is zero, that means person is male. Okay, so why to take two columns if one column is sufficient? Okay, so that is a reason actually, okay, we are doing this. Okay, so that is a reason we are dropping the drop first equal to true. Okay, so that is the reason we are doing this. So gender only male. So sometimes gender value can be zero also. That means it is female. Okay. Similarly, married, yes, is zero means it is not married. Okay. So why to take two columns if it can adjust with one column? Okay. So that is the thing, guys. Okay. Okay, so we are trying to increase the columns. So now obviously before it was 12 columns, now it is 18 columns. Okay, so that is a difference. Okay, because a computer can understand 0 and 1, model can understand 0 and 1 only. Okay, so it is important to convert the data into 0 and 1. Okay, one hot encoding. Okay, so it is also called label encoding. So converting the category into numbers, numeric form. Okay, I think it is clear now. It is easy. Okay, so removing the columns which we don't want. Okay, so gender, why to now take the gender as we already know it's male. Okay, so removing all the unwanted columns. Okay, okay, so guys, this thing we have done already, I think. Okay, so I shared in the notebook. Kindly try it once. Okay, yeah, okay, so main thing is this. Okay, uh, okay, so we are filling the missing values with the mean value. Okay, so we are missing values we can fill with mean, median, mode. Okay, so here we are using mean. Okay, so this is the in place means which is changes we are done in the original data frame. Okay, so guys, you need to have basic knowledge of machine learning. Okay, so we have done entirely the course on machine learning for 2-3 months already. So these guys already know this. But if you are new to machine learning, then you have to start doing these things. Okay. Uh, yeah, okay. So guys, this is the main thing here. Okay, so about the neural network. So first we imported the libraries. Now, why to use Sigmoid? Because person will buy the insurance or not. Yes or no. Okay. So Sigmoid will give answer. Okay. In the form of probability, how much is the probability that a person will get the loan? Sorry, loan. Okay. So so yes and no, so both probability we will get, and if you add them, it will be 100%. Okay, it will be one actually. Okay, so sigmoid is used for that purpose. Okay, and this is the hidden layer, guys. So input dimension, number of features, how many columns are there 12 columns. Okay, so 12 things are easy. Okay, so hidden layers are the ReLU activation function. Okay, this is the summary of the model. Okay, so these are the parameters. Okay, and why we are using binary cross entropy? Okay, because we have two categories now. Okay, that's why. Okay, optimizer Adam, we are trying to find the accuracy because it is a classification problem. So matrix will be accuracy. Okay, so guys, things are easy, things are repeating. Okay, so please focus. Okay, we train the model. Okay, here we set the epoch as 110. Okay, so if you see after 110, what is the accuracy? You have to see like this. Okay, so accuracy is 78. You have to see the testing accuracy. Okay, is there any difference? Some difference is there. So that means overfitting is there. Little bit difference, not much. Okay, so little bit overfitting is there. Okay, so when I train you, you answer me very correctly. So you got 82% accuracy. But when I say you sit in the test, do some questions, then you get this marks out of 100. So they are close actually. We can say that it is close. Okay, it should not have much gap. Okay, so that is the way you can see the overfitting problem is happening or not. Okay, so guys, please try this. Okay, so 83% is the accuracy we are getting. Okay, and we are again plotting this. Okay, so as the epoch increase, accuracy also increase. As the epoch increase, loss is decreasing. Okay, this is the loss. You can see also loss. Okay, validation loss and the training loss both are decreasing. Similarly, training accuracy and validation accuracy both are increasing. Okay, so guys, I'm sharing with you this file also. Okay, so do it. Okay, so this is the two things you have to do today. Okay, so I explained you. Now try the convolutional layer. Okay, again the same thing I will tell you. Okay, CNN layers, kindly add it like convolutional layer, max pooling layer, flattening layer. Okay, dense layers like okay, so output layer. So everything you have to do now. Okay, so I can just guide you what are the things, how you can solve it. Okay, how you can take the help of documentation. Okay, but at the end you are only the person who have to do it. Okay, so guys, I'm sharing you both this note, both this on your WhatsApp. Okay, so anyone started? So guys, please start. Okay, and this loan data, this CSV, I will send you on WhatsApp. Okay, this I can find you. So guys, if you want to find any file, so you can Control F, Control V. So this is the CSV file. Okay, so you can read always before doing anything. What are the columns we have? Okay, so loan ID, gender, it is married or not, education. Okay, uh, these things you can read, guys. So whether the person will get the loan or not, person is living where. So please read it. Okay, I will share you this in the break. Okay, kindly attempt it. Kindly add convolutional layers. Okay, tell me the output. Okay, play with this code. I am giving you time today. Okay, so whatever the learnings you have done in past 3-4 days, use it, apply on this, play with it, then only you will be able to learn. Okay, yeah, good. Yeah, I'm sharing on WhatsApp everything. Okay, so guys, let's take a break of 15 minutes. Okay, and after that, you can continue with your these two programs today. Okay, so yeah, okay, so let's take a break of 15 minutes, and after that, we will continue. Okay.
Recording stopped.